had mentioned, I'm an improver. When we're here, welcome to Improving. They got us the pizza, got us the room. Improving is a software consultancy. One of the key traits, though, with that is you can have a lot of people with the mercenary mindset in consultancy. Oh, I'm a contractor. I'm here to take orders. That doesn't work. If you've got a bunch of contractors running around for you, what's the difference between us and having an offshore group? The main difference is that when an improver joins your team, we're trying to actually solve the problem in your best interest, not in the one that gets me paid. So if I think you got the wrong guy, I'll tell you. If I think you're doing the wrong thing for the project, I'll tell you. If I think that we can make it that way, but it's more expensive, I'm going to tell you. Because my goal is to build trust in a way that matters. And that means that I have to show that I'm putting your interests ahead of mine. And that I'm going to add my insights to yours, not just leave you doing what you already need to do. We offer services in software development, app modernization, data science, platform engineering, just a little bit about everything you want in tech, we got you. And if you're willing to work with a wider market, we can hook you up with groups way outside of just Houston. We've got people out in Atlanta, we've got Dallas, we've got out in Minneapolis. Heck, if you want to go and out to Canada, we've got people there, as well as other options for nearshoring and offshoring if that's what you need. The trick is, give us a call. Now, with that said, one of the things we like to do to make certain that we're giving back, not just consuming from our communities, is share our expertise. And this talk is one such. Borrowing the expert's best 3 software patterns you need to know. Now, for those of you who know me, you know I don't tend to do technical talks very frequently. I much prefer the philosophical or the leadership-oriented talks because I think those are the ones that end up being force multipliers for software development teams. This is one, though, that was a force multiplier, but very technical. So today, the intent is, hold on, we'll get to that in a second. The intent is that we're going to go through the 3 patterns that I have found in my 10-year career that I have used the most and most frequently. They are my go-to tools to solve most computing problems. We're going to talk about what they are. I'm going to provide you some analogies to kind of help you grok what the thing is, and then I'm going to show you a trick that I've learned to do with them over that time that I keep going back to. This does mean that we're going to be in the code only a little bit, but if you want, I can show you some of what that looks like, because as an added thing I can add to this talk, if we can get enough time, I can show you how to prompt AI using these patterns and why that's more effective. Now, who's this guy talking to you up on the stage? Well, we already alluded to part of that. My name is Daniel Scheufler. Things you should know about me before I go off my spiel. I'm a Christian, a husband, and a father of 5 children. So, if you have anyone to thank my wife for letting me get out here this evening and not be home watching 5 kids. I'm an improver, but in particular, I have put my bent in the 10 years of my career on leading software engineering at scale. Whether that is dealing with quality, TDD, building up unit tests, or setting up CI/CD pipelines, or, honestly, the pride and joy of my stuff is leading teams to outperform their peers by doing software development excellently. This is a thing I try and bring wherever I happen to be, wherever I happen to start, we're progressing that direction. Now, I have, of course, a blog, which you can find at daniel.scheufler.tech, as well as a newsletter. Personally, I recommend the newsletter. You'll get it delivered directly to your inbox rather than having to go to my blog to figure it out. And you'll get a chance to sign up for that with a special deal at the end of this talk. But before we begin, the entire point of this meeting is not about me standing on the stage and preening like a peacock. Rather, y'all came here hoping to learn something, probably from the title of what I was talking about. So I want to take a minute to go around the room, and if you're willing, I'll write down the things you want to learn so we can check them off as we get through the talk. And since I know several of you in the back, I'm going to start with you guys. Yes, that guy behind you, Tony. Can you get him up here? So, John, what would you be most interested in taking away?
I'm going to take the easy way out. I want to learn the patterns that make you most successful as a developer.
Okay, so what are the patterns? Definitely easy. Enrique?
You know me that one too. I mean,
dude, you were sitting in the blast radius. It's one direction or the other.
Right, I know. Definitely understanding that, right?
Yeah.
I mean, obviously the title was just giving it away, and it's just really understanding how they tick. Because definitely it's like, okay, yeah, I know the pattern, but how do we apply them, right?
Yeah. How do we help teams adopt it?
Right.
Making change is always harder than saying, here's a great idea.
Yes. I mean, how do you convince them, right? Like, yeah.
Excellent. I like that approach. I will ad-lib on top of that. I can definitely incorporate it. All right.
I'll give him a choice.
Yes, he's not wrong.
You've been here before.
Ryan?
How do you know which pattern?
How do I know which one to use? Okay.
Yes.
Good question.
That one's a hard one, but I love that question, and we'll see if we can dig into that.
How do you weigh in the cost of maintenance versus, pre-planning? So if you wanna obviously reduce the cost of maintenance down the road, how do we pre-plan to make it so, especially given the fact that sometimes I can take a lot of pre-plumbing and all.
How do I balance
Yeah,
the migrate, the mitigations versus big plan up front?
especially the end user or the end client has
Yeah.
no idea what I see, how you're gonna.
Right, are they gonna really be willing to pay for this extra?
Exactly, they wouldn't know it until it's too late sometimes.
Yep, so how do we get them just enough that they're not gonna hate us?
Buy-in, how do you get some buy-ins?
Solid, okay. Tony?
You can say I'm really just here kind of crawling the user review, just listening for anything that I haven't thought of before or.
Alright, so he's here for those weird tips and tricks, got it.
Building an internal index.
Yeah, there you go, that's it. Build an internal index, so.
Alright. Easy, John. You good, sir. John?
Yeah.
I remember it!
Okay. Is one pattern better for a language than the other?
Okay. So I'm capturing that as, do they fit a particular language better or not?
Right. Like is C# better than let's say C++? Or
The short answer is, it depends, but I do happen to prefer C# between the two of them.
We can say yes.
Alright, Amit?
Well, you mentioned prompts if you have the time, but I do like the idea of looking at the prompts because that's going to help you structure and get code that's has a better chance of being well structured, right? If you want code coming out not being so great, and so yeah, using those that's a nice promising direction.
Solid.
Hi. I don't know if it's you're talking about, but what if for all this time you invested in the wrong technical decisions and you realize it's wrong and you have to figure out how do you deal with there's like global rail, I guess. How do you deal with all this stuff?
I deal with the consequences to a team morale.
Okay, so that one does take us a little far afield, but I'll see if I can bring it in at a point, and if not, hit me up afterwards. I'm more than happy to share my thoughts. And Charles?
I guess the advantages and disadvantages of the three platforms.
Solid. Advantage or... Excellent. Alrighty, so I'll try and refer back to that as we go through our session. Thankfully, a lot of that's fairly well aligned, so I won't have to do a complete backfill of this content, though I have done that before. You can ask John at one point. So, without, too much further ado, I'm going to give you the ending before we start. Here are the three patterns: strategy, adapter, decorator. If you can learn those three and what they look like in your language of choice, you will get, so far it's not even funny. But along with these things, I want to point out a couple of patterns. So first of all, you'll ask about like, hey, do they fit certain languages better? Oddly enough, it's been my experience that strategies are effectively object-oriented languages trying to figure out how to go functional, with functions being a first-class object before they were a first-class object. So how do you make it that? You wrap a class around it. When you talk about the adapter of the facade, it literally is hallucination before it was cool with AI. I don't like that interface, I'm going to make my own. And lastly, decorators are like the code version of the Manchurian Candidate. It says it's doing this thing, and several other things it doesn't recognize it's doing, or if you prefer, the Matrix, depending upon your movie references. Now, let's dive into the strategy. Pattern number one, functional in your object-oriented language. This is the answer for how do I pass around a function like it's an object before that was a thing. Back in C++, you could not pass a function on its own to an object. It had to be written into a class. So how do I make it that the behavior of a class can change over time depending upon how it's configured or the situation it finds itself in? Well, I can either add an endless list of if-else statements or a switch case, or I can write that function in a class and then pass the class in. But the class, I have to be able to tell what type it is, I have to know how to use it, and so we get interfaces and types, which generally follow what we call a strategy pattern. Now, if you're asking yourself, why did they call it a strategy? What exactly is this thing? The most common model you'll see in books lists it as an alternative for, say, computing the tax on a currency. You use this one for Great British pounds, you use that one for yen, you use this one for dollars. Strategies. It's a strategy for tax computation. And all of them have the same declared interface. I am a tax strategy, I have the compute function, and I take your dollars as input, or whatever the thing is, and I'm assuming it's in the right unit, and I'll return the result in the right unit. That is, literally, you go from some function, given an input, yields this output, the same for every strategy, and you'll get something that complies with that interface. I strategy with an invoke method that takes A and gives you B. You're literally wrapping a function in a class. Ta-da! Now, here's the analogy that I find helps make that make sense, right? So you got just some function. In this particular case, we're talking electrical power. And this is how I get my electrical power outlet. That little thing right there. And this is the one you'll find in your home all the time. But there are different ways to get electrical power. You could get a battery, you could go off your home, you could get a jackery and get your solar power going. But all of those at the end offer the same thing. They're just different ways to get power. They come with their different drawbacks, but as long as I can interface with it, I can get electrical power. That's what the value of the strategy is, because now I can essentially say, I'm going to put the same handle on all of those different accesses to electrical power, namely my plug interface, the 3-prong. And I'm going to attach it to all of them. And then anything I want that can plug into that suddenly has electrical power. This is the value of the strategy function. You can drop it in the slot, whatever fits. If you want to add behavior to it, okay, create your own strategy. You want to extend the functionality of your system from going from dollars and pounds and yen to now South African dollars or Australian dollars, add another strategy, small extension. You need to fix US tax code because they changed it again? Cool, don't worry, you don't have to retest the British pounds. They're safe. All of our design principles, the solid principles, right, are protected when you use a strategy pattern. Now, that covers the how do they work, this one just for the strategy, right? It's just a function like you'd have any other way, but you have a bunch of them that have the same interface, and so you pass them around like they're a class. But it also gives you some additional benefits. Consider if you're not actually implementing this special currency online, say Ethereum, and you have no idea what the tax rate is, but there's an API for it. So long as you can wrap the API call in a strategy that takes my stuff and returns my price, it's a strategy, and you can extend your system. And honestly, I don't care what's going on underneath. If it's instead, I need to configure this on load, I need to grab something from the database real quick, you can have that be part of the setup for your strategy. So it's not loaded every time I'm doing the computation. I just add startup. When I create this class, I've got the extra data I needed. And I don't have to now wire that into this giant God method of tax computation. It's only affecting the one that has to load from the database. These are the kinds of flexibility you get when you use a strategy, but it all comes down to that same thing again. I'm doing the same behavior, given A, give me B. But I'm doing it different ways or for different reasons. Now, I've talked about this in terms of money. What other options might there be? Perfectly appropriate. How about logging? When I log, do I want it to go to the console? Do I want it to send an email? Do I want it to print me a pretty picture? Whatever you happen to need, do that. It could be that I need to generate an output. This one needs to generate a docx, a document, or maybe Maybe this one needs to do it to just a text file, and this one needs to do Markdown, and this one needs to do a PDF. Strategies. Same function, print, different behaviors. Anywhere you see one of those coming up, this is what you do. Now this actually comes up a lot in, say, the front end, say React Redux. Those languages are going to pass you state, and you're going to make a modification on state and hopefully return state. Strategy. Just a different strategy for each UI event. Same kind of pattern can be used for APIs that have this different kinds of events, same behavior, just routing. Now, I've waxed poetic about this thing for a moment, so let's talk about one of the tricks. This is one of my tips and tricks. Can y'all actually see that in the back?
Yep.
Good. All right. One of my favorite things that you can do in C# is a unique feature, as far as I know, to C#. It's called reflection. I can get access to type information from the system itself. I can grab it out of the assembly, and then I can do logic on that type information. This is not normal. It's a form of metaprogramming. But one of the most wonderful ways to use this is if you have your iStrategy fit pattern, and that defines like all of my tax computation strategies. Well, naturally, you don't want to have to mount each of those in your calculator. You would rather use dependency injection. How do you add those to the dependency container? Reflection. You use the fact that they all implement this same interface to discover the set of them, and you can see that here, right? Types is equal to get the assembly, select many of the types of this thing, and then filter those things for where I can assign this interface from my type, and that type is a class, not another interface, or not an enum, or not gosh knows what else. And now I'm just dealing with the class implementations of iStrategy. And from there I can then just say, hey, for each of those, mount an implementation of this interface for blah. Now, as a trick, one of the things you will need to recognize is, right now my strategy isn't super clear about what kind of situation it handles. So how will my UI know which one it's supposed to use? The best thing I've found to do is to extend this class just a bit with a property, or really a function, that states not only do I do the thing, I can also tell you, can I do it with the input? Return true or false. And then you can use that to go through the list and say, find me the first one that says I can do it. This, again, is how do I associate these pieces together? And it is specific to how this will look in C#. You will find the same behaviors, the same patterns, the blah, showing up in multiple different languages. This is what it looks like in C#. You'll find the same behavior in JavaScript, except that JavaScript simply treats a function like it's a strategy. And so long as you can collect your functions and associate them to the right moment for invocation, ta-da, you have a strategy pattern. What I want you to be aware of is that the strategy was the first place I realized that the different programming paradigms, object-oriented, procedural, functional, have a significant amount of overlap. They are all trying to solve more or less the same problems, and depending upon the age of the solution, the language itself, they had certain shortcomings. Strategy emerged as the object-oriented response to I can't pass a function around. They eventually built it into language. But that doesn't mean that it's not a useful approach. In fact, most recently, I made use of this in terms of running many different index calculations for product prices. We would take various different source datas and run the same kind of computation, but they were all coming from the same list of index records in the database. Why was this useful? Because by separating the computation for this index, which was an averaging index, and this one, which was a greatest and least sum index, and this one, which was a weird windowing index, I can test each one. I don't have to run a giant store procedure to hope to God they all work, or run the whole thing all at once. I can literally pull this one out and say, for this example data, did it work? Because the strategy also allows me to isolate my behavior from the system and from all of the orchestration that has to happen before the behavior is useful. I can just say, you take A, you should have this B. It becomes just a function. But now I can test critical components of my application, computations, taxes, the big, scary, important stuff, and be absolutely certain it's correct. So much for advantages. Disadvantages. Strategy has the unfortunate pattern of proliferating files in your code base. There's not a lot of ways around that unless you try and mash them all up together, and please don't do that. But especially for someone who's not used to this, they will look at you do that, and you'll suddenly explode the number of files you've got, and they'll pull their hair out. Honestly, I don't regard this so much as a disadvantage, except if you're used to navigating manually. Most of your IDEs are very capable of managing navigation by F12, or some equivalent. If you have proper folder hierarchy, this isn't a problem anymore. But it can freak people out because all of a sudden the file number exploded. Thankfully, it's because the line count on one of your files dropped. But be warned that it can make navigation a little hairy if you don't have very good names. Because if everything is pricing strategy underscore the currency, you're gonna have a bear of a time finding anything. So here, when you pull a strategy, make certain that the strategy itself, an I blank, is clear. And it should be about what it does. What's that invoke mean? I currency calculator, I tax calculator. Those are useful. I strategy is not. Naming matters. When you name the strategies, make certain the thing that is different about them goes first. So that when you go to read it, it actually makes sense. Now, all of this is just for strategies. Before I jump to the next one, does anyone have any questions they'd like to poke at?
I was just thinking that the strategy pattern and the mediator pattern are similar in all regards.
Where the
They're
mediator
not
is
the same.
generally message passing, right?
Yeah.
Yeah.
What would you say the difference is between the strategy pattern and the provider pattern?
The provider, for its name, literally is going to provide you an instance that does blah. So in my mind, it's more similar to the factory than necessarily to the strategy.
Okay.
Where it can, however, provide a method that does this, and so it can just do the thing. It's a different approach. And so I would suggest that the way you determine which one you want to be using is by your starting condition. Are you able to know ahead of time what the complete list of these strategies are, and you will not have extras, where the provider can allow you to create on the fly these things because of how it's being used. That'd be where I'd go to for that, but I'd have to dig into it to see if a particular problem fit provider, strategy, factory, or visitor as the appropriate model.
And this question brings up a good point. I'm sorry, was someone else having a hand up?
No, you're good, go for it.
I was saying the question brings up a good point too, that a lot of these patterns, well, I mean, you distill them, a lot of them do have overlap. So it's like, you could try to do the same thing with like X, Y, and Z, and it's less a question of, you can't do it with the others, but what's the most appropriate one? And that's where understanding the trade-offs is, just because there is that level of overlap. And provides a great example.
So with that, I'll offer, we haven't touched on does it fit a particular language well? This was Object-Oriented's answer to functions as first-class objects. Since those are no longer as needed, it may seem like strategies are no longer the right way to do it. Disagree. I think where you have a compiled language, like C#, strategies offer a bit of clarity for how to interact with and manipulate the program in a predictable fashion, where an arbitrary lambda or function you just declare doesn't. I personally believe that having the strategies as a class that can be invoked provides a lot of benefits, especially in the case where you need to load a bit of configuration, or you need to take a novel approach to accomplishing the same outcome. Because the class allows you to encapsulate, literally, more of the information, more of the configuration, more of the support method that might be needed, where a single function can't. Now, the last piece we have is like, hey, how do I weigh the maintenance cost versus the upfront on this? As far as I'm concerned, the moment I know I'm going to have at least 3 different kinds of behavior for the same stage of the pipeline, strategy. Automatically, I don't ask. I'll build the first one, I'll build the second one, and I'll do an if switch on those. The moment I get the third, everything's going to the strategy. But there's a trick to this. I have to be confident that that third one represents a genuinely unique case. this. Otherwise, I don't know enough to effectively genericize the behavior, right? I don't know enough to be able to state, I'm going to jump back a little bit, my given A yields B. Until I have seen 3 unique cases at least, I don't know enough. And what I've found, especially in the maintenance stuff, is if you jump to strategy too soon before you've actually seen unique cases, you kill yourself on the interface of the strategy. Because you don't know what the inputs have to be or what the output can be. You didn't draw the line correctly. So be very careful when you do that. But once you get to your 3rd case, you know enough to create the first generic version. And it will also tell you sometimes when maybe that shouldn't be handled here. So much for maintenance versus wait on front. My vote is the moment you notice you need it for a strategy, jump on it.
Hey, Daniel.
Sir?
So the reflection angle that you've got on here is obviously unique to C#. You can do some similar things with JavaScript, right? But when you introduce this, it's still the strategy pattern as far as how it's behaving.
Mm-hmm.
The default strategy pattern deals with if you have a context object and you're doing a set strategy, and then you call that context to execute the strategy, right? So it's more manual. With this introduction, does this cross into any other patterns? Is it now more overlapping with other patterns we also might recognize?
In particular, the one that I find most commonly dealing with this is factory.
I was thinking that.
So anytime I run a strategy, I'm almost always reaching for a factory immediately next, because the factory is the way I abstract the how do I pick which one I'm supposed to use.
Right.
So that the context, the thing that was supposed to be trying to run these strategies, stops paying attention to how do I get this thing up and running?
Got it.
And instead I hand that off to a factory, which will hand me back, here's your object for invocation.
Okay, I can see that.
Yeah, but those two most commonly go together. You don't actually have to, but I highly recommend it.
Yeah.
Especially when you get more than 2 things,
Right.
or anything even remotely complex in terms of
I
initiation.
wouldn't see how this would be as useful if you weren't using a factory, right? Because then you have these independent objects that would all be checking for, hey, is this applicable? Which would still work.
Yeah. The time I have seen where I didn't need a factory for was oddly enough this index computation example, where I knew every time I have to invoke all of them.
Right.
So I didn't need a factory to pick them, I just need them all stood up,
Yeah.
and then 1, 2, 3, 4, 5, and I could just append new ones as I had them.
Right.
But you're right, most of the time you need a factory with anything that's going to be a dynamic programming type situation. Enrique, did you have something?
I was gonna say that strategy leads to factory in that way, or like it's just like Bannon and Robin always together.
They kind of go together.
Okay.
So the moment I get more than 2 strategies, there's going to be a factory that helps me pick among the 3.
Got it.
And then of course you test the factory to make certain it's handing back the right one, and you test the strategy sheet with each of them doing the right behavior. But it allows that level of abstraction, but you don't have to. It's just the most common thing I see happening. Factory plus strategy, but strategy is always the thing driving it, because I see the need for strategy first. Solid questions. So with that, let's dive into the next factor. Oh, hold on.
Just a remark, when you keep saying strategy, keep thinking of SQL databases, like the right query strategy.
I can see the connection, yeah. And you can use strategies kind of as an overlap there, especially when you get to interfaces with other systems, other libraries, other programming languages. These strategies can be a way to cover over some of the edges of handle it this way for this one, handle it that way for this one. Say Postgres versus SQL versus Mongo.
Or an internal optimizing strategy for dealing
Yep.
with the joins.
Yes, exactly. So, pattern number 2, reject and substitute. For those of you who don't know this is Adam Savage from the Mythbusters, one of my childhood heroes. I reject your reality and substitute my own. This is what an adapter does. It answers, how do I use that thing, but my way? Or put it in the functional terms, I have my function given A yields B, but I don't want a B, I want a C. How do I get that? Or strike that. I have C, I don't have A, but I could probably use C to get A. Can I just hand you C and you do the thing? That's one option. Or yield the other output. Here, again, we're going to go with a visual analogy first, right? You got your function, but you want something else. So the easy example is like, well, I've got a different kind of electrical power, but I still want to get it out in the US 3-prong. Okay? Well, there's your adapter. You can now hook up into the EU standard. Oh, and by the way, I threw in USB for you. Or it could be, you know what? I want something else entirely. I'm going to take that EU power, but I want to go into like industrial strength. Okay, maybe you get a little weird here, but you can do that. This is the adapter, right? Like literally, we call these things an adapter because that's what they are. They are taking access to something else and doing a translation so I can get the behavior I want. In software, this often looks like, well, I'm going to wrap that API that came out of that library because that doesn't make any sense. Or that doesn't match the language already in mine. One of the examples I had for this was a situation where we were pulling in a drawing library. But one of the words it used for it was so generic as to be useless. Shape. Okay, that's everything in the library. What shape is this? This one's a circle. Get circle method. And you feed me a radius. And it'll construct the shapes that make a circle. Or, hey, I'm trying to do this, and like it had an overlap with the geophysical term, so it couldn't be that. We had to give it a new name, just wrapped a class over it. An adapter. The adapter allows foreign information, foreign code, foreign behaviors to interact well with your existing system. Either because of the sequence in which you initialize them, or because you don't want to have to stand up an API every time you're going to call one of the methods, you're just going to leave one standing, the adapter handles this for you. It's a form of abstraction. Of course, you can kind of chain these together. You're already hearing me say that, right? Well, what if I have an A, but I want to get a D? And I know there's these intermediate products, B and C, that I can use to do that. I'm just going to hook them all together. Well, okay, cool. But then you get like this laptop adapter. It takes my regular 3-prong, and then it's going to rectify that into digital signal, and then it's going to constrain the voltage, and then the voltage is only going to be what's safe for my laptop. Oh, and by the way, there's a surge protector in there too. Bunch of stuff. That meta adapter, or the adapter on an adapter on an adapter, becomes a facade. I'm just hiding everything of how it actually does it. You just have this input and this output. Facades are great because you can essentially take an entire library or an entire suite of tools, chain them together, and create an interface that never existed in the first place, custom for what you need. This is actually similar to what I was talking about with this circle method. I can either create an adapter that just gets me the circle, or I can create my entire own shapes facade so that every shape I need, I can just call. And the facade handles all the initialization of the special shapes libraries. It'll even remember and cache them for me. The facade is an extension of behavior on top of the component parts, where I might have had a library that says these shape methods, draw shape, delete shape. I can have all of that together now in the facade, draw a circle that so and so. As an option. Now, we're going to get to that in a second, but that'll get us way down there. The adapter, the real way to think about it, really just boils down to show them this. You show them this, 90% of your engineers will get it. The trick is in finding a situation where it's useful. Thankfully, most of the time it's not. But there are those times where the pattern that a library wants to be used in doesn't match the one that your code wants to be used in. For example, you could get a library that's natively synchronous, but it's being called by asynchronous code. You need to wrap that so it jives. Maybe you've got an API that has rate limiting. So this call still needs to be asynchronous. But if you hit the rate limit, you don't want to immediately fail out. You want to kind of slow that down and pull it through. Who's going to know that? The adapter, not everyone. So you can either accrete new behaviors on top of it to make it a little safer, or you can have it change mode of interaction. Maybe this thing goes to a database. Great, it's just fine. But it's coming back and it's giving me a table, and what I really want is this like JSON version of the view. Okay, cool, adapter. Adapter purely comes down to, I already have the thing that does what I really need, but it's not speaking my language. Okay, fix it. And again, adapter was object-oriented's answer to this. Functional would be just chain the function. Do the thing, chain the results immediately into a translator function, and then take that. Adapter. Change the interface. Now, this is one of those ones where weighing maintenance versus design up front, I find this coming out more in older code bases, where I have this thing, it's already there. But when I want to add new behavior, it's got this entire new style. And the old code base doesn't understand. It cannot interact with that. Okay, so I'm going to adapter onto my new stuff, and the adapter will essentially become a facade. It's going to handle all the authentication, all the rate limiting, all the fancy jazz that's going on over there, and make it very simple and straightforward for the other thing to use. But all of this can't be planned out ahead of time most of the time. It emerges, in my experience, from discovering libraries that are applicable, or from finding the, well, that didn't work, or any number of these things that happen as a natural course of development, or needs that weren't anticipated. Most commonly from a system that has kind of built up over time and has a very strong opinion of it should be this way, but that library works really well, so we don't want to write it ourselves. Okay, cool, adapter. Because it allows you to plug these things in without having to completely retool your system. Just like, there's an existing power grid, but I want to use my US power charger. So far, so good? All right. Now, let's go to the next stage, which is this. This is going to lean extremely hard into functional programming. This is something you can actually do using LINQ. This style you're seeing is more of the JavaScript, isn't it? But rest assured, this same pattern of adapters, I have used frequently in LINQ to make the thing obey. Especially when I'm dealing with computational projections from database objects. So in this particular case, I've got the example of several line items in a cart. I want to get, how much is it going to cost me to expedite these items? And I've got the list of items I know that need to be expedited, or at least there's a list there, right? The first thing I'm going to do is I'm going to go from all items to just the expedited items. And then for those, I'm going to map the results, which means each of those is going to now become the result of this function. Get extra cost for line item. And then from there, I'm going to take the list of these line items, I'm going to reduce it from a series of results to a single instance. Now, this pattern of filter, map, reduce happens all the time when you're dealing with arrays of objects. Here's essentially what's going on. I'm adaptering, I'm adaptering, I'm adaptering, with one strategy. The first adapter says, nah, I don't want everything, just the stuff that matters. It's a filtering function. It changes my given array of A to an array of B. Smaller array. The next one is a map function. I am going to change types here. This could be mapping from a computation, like compute a cost, or it could be mapping, translate it from this form to that form. It's a translator function, an adapter. I have my array of B. I wanted, honestly, just one value. From my array of A's, just give me the cost. Okay, I'm going to facade this thing out. We've done this map, and now I'm going to take the list of values, and essentially I'm just going to add them up. That reduce function is just a summing. But it's an adapter. It took many and reduced one. And now by stitching together multiple functions, I can create that facade chain. Given my array of A's, give me an array of B's. Given my array of B's, give me an array of C's. Given my array of C's, give me a D. And from A to D, one function. Facade. Now, I happen to like functional programming. Most of the C# developers who I've worked with don't, because it's hard to figure out what the heck the thing is doing, unless you can read filter, map, and reduce as what they're doing. So this is one of those moments where, buyer beware. I just put in a fairly complicated algorithm in 5 lines, but it depends on the developer supporting this to know what each of those lines did. I still personally vouch that this is the way to do it because it reduces the chance of something going completely cattywampus in the middle of that while they're trying to run the extra cost. How many of you seen in a for loop, someone, here's sum for each thing in this, here's my computation, add to sum. And it only takes me one character to screw that up. You delete the plus. And now all of a sudden, sum is equal to the last sum. I kid you not, I saw that error this week because of this same problem. It's not their fault. It's a single character in 600 lines of code busted everything. There's a reason why I like my functional. Because it also forces me then to separate, okay, so what is this mapping behavior? Well, go and implement it over here. It forces it to be separate because I'm calling it. Now, can you achieve this with a regular for loop? Yes. But recognizing that what you're doing is stitching together translator behaviors is a new way of thinking about composing your programs, as composing it as a sequence of projections from A to B, from B to C, C to D. And if you can separate the complex flow of I need to get the expedited costs into those components, dark parts, you can reason about your program in new ways, especially when you're talking in terms of design. In fact, this is one of my favorite design up front tricks, is I'm going to start with, well, what do I have to start with? I got A, I got B, I got a little bit of C, and I've got this E thing. Well, okay, what can I get by combinations of those? Well, I've got an API that goes from A to the rates, mapped to A. Cool, want that. If I had the rates and the A's, I could go feed them to this other function to get me the taxes on them. And of course, from taxes, I can get the sum taxes. No problems. But I can begin reasoning about what I have to do for a complex workflow in incremental steps of, if I had this information, I could get this. And then it'll expose pretty quickly, well, in the chain, I know how to get all of this information except that one. What do I need to get this? Which tells me what do I need to go get, what do I need to go build, or who do I need to go bother? So much for the advantage of an adapter. Disadvantages. It hides stuff, straight up. Because it's wrapping the potential misbehavior of a library, of another class, of anything, under an interface you like, which strictly means it's encouraging you to lose visibility about what's going on underneath. So unless you know what it's doing, it can be very easy to say, well, why isn't this thing behaving? The obvious way to call this structure is like that. Yeah, except that the adapter doesn't work like that. Not really, because the moment you lift up the hood, you see it's not running a V8, it's running the mousetrap. Or something. But again, I tend to find this one emerges over time rather than being built in up front, but that you can use it at the design layer, provided you're willing. Before we jump to the next pattern, are there any questions?
Two questions. I know this is an example. That bottom function in general returns a value, type, or a behavior. Bottom.
So that bottom would have to return a value.
Okay, good. And then the second question, you guys, I mean, with what you do is, when you obviously that get extra cost, potentially in this case because of debugging will have like certain level of logging. Do you guys log everything here and then just not let it, and then kind of eat up the exception and then just let it continue the flow? Or you stop everything here because it's going to get cumbersome?
So I would generally favor a swallow exception approach for this, where to do this well, this step has to become no longer type safe.
Right.
I have to be able to give it an optional.
Right.
I borrow from a technique known as railroad-oriented programming for this. If you guys want, check out the blog F# for Fun and Profit. It's where I stole the idea from. But it basically assumes that there's one way into this function, but there are two possible ways out. There is the I succeeded and there's the nope, I didn't. When I run this, I'm converting from a I have a definite value to I might have a value, which is how I swallow the exceptions, because the I might haves will return there's nothing here.
Right.
Which means that everything after this, going down however many steps that is, must be able to handle the I didn't succeed steps. And in some way log that, so I know. The exception try-catch logic will usually have the logging so I can trace it. This line item failed, here's the exception I got, proceeding. that means that at the bottom, I can't trust the sum anymore, can I? And so now I have to have the conversation with the developers, is that a complete failure? Or is it a partial failure with like a little asterisk? My tendency, I'll have it as a partial failure and find some way to bubble that up to, hey, it's this plus. I don't know what the end is, but it's at least this much. But there are situations where that's not the right choice. I would recommend choice on that, but my preference is swallow it and make certain that you favor the railroad. It succeeded or it didn't, and you have paths to support both tracks. Solid question. Any others?
Would you consider this a more complicated example of an adapter pattern? It's not the one I typically see.
Oh, this? Yes.
Yeah.
This is moving very much towards facade. The reason I show it is very specifically for the use of the adapters in what I described as functional alchemy. I've got all these little pieces and I can chain them together to create the mutation. But I need to know all the little pieces, and it will very quickly highlight if I have a step in my algorithm that I can't support yet. But yes, this is one of the more complicated. This is the tip and trick. This is not the do this normally.
Yeah. So I think the adapter pattern is still incredibly powerful, but it's a lot simpler than this.
Yes, no. This is the let's go off the deep end pattern.
Okay.
I love it. I think it's cool.
No, he's totally right. Because, like, remember how I said, right? Most C# devs, they don't like functional programming. For good reason. This is complicated. Unless you know what it's saying.
You have to use link.
Yeah, but once you figure it out, a whole world of possibilities opens. If you learn. By the way, pay attention to that. That's one of the underpinning themes in this talk. Once you figure it out, once you get this thing, you're going to start noticing a pattern across all of these patterns. Tell me. I saw you give me a little head nod. You got a thing?
No.
All right, I've been asked to leave him alone. I'll leave him alone.
So have you, this particular
That's not what I said.
really good actually, but have you put some any authentication code to external APIs and that get extract items?
I try to avoid that. Most of this I try and keep entirely local
Internal,
to
okay.
the execution, because if you do the other thing,
Yeah,
you run into a lot of potential problems. Now,
Yes.
I have used a simple pattern for threading, where the threading is going to be I/O bound, not CPU bound. And that one you can still get away with it, but you have to change the stuff leading up to it so that it feeds memory safe information into the thread. But that thread just becomes another, well, given an array of A's, I get an array of B's. It just so happens that the thing it gives me back is an array of tasks. And then the next step you have on that is either a task wait all or something. But again, that gets us into the railway-oriented programming. Okay, it might work, it might not. And I need to make sure I can handle both cases when I come back. Typically, I'll try and push more of the processing local to the memory safe entity at that point. But again, that's a choice depending upon what I'm facing. You give me all sorts of fun little areas to go and tease with this. So, pattern number 3 for the night. Manchurian candidate. Or for those of you who don't recognize it, think of it as the matrix. You wouldn't know that you were in the matrix until you're told. So, this is the answer, hey, I want to do that, but I also want to do this thing, but I can't mess with that. Or if you prefer, I still need to maintain given A, do B, but I want to do a little more. How do I do it? As you might guess, layers. Onion set layers. This one being the decorator. The decorator has layers. This is a 3-step decorator example. Whenever you're like trying to type an input on a website, or you're trying to run a bunch of computations, say multiple possible inserts to a table, you don't want to hit them all at once. You really don't want something writing to the same thing multiple times. You want to protect that a little bit. You might add a debounce. You might also want to check it for, hey, how fast is this thing running? So you'll start a timer. And then you actually do the thing, whatever that thing is. But you didn't want to write the timer logic and do the thing. And you didn't want to write the debounce and do the thing, because the debounce has nothing to do with the thing. Same thing with the timer. But when you're done, you want to stop the timer, and you want to release the debounce so that people can go do it again. You've wrapped additional behavior transparently around the original. This is one of the most wonderful forms of programming, but It's not obvious. Because the way it shows up in C# or blah is with this little square brackets thing on top of the actual declaration. You could miss it if you blink. Single line adds additional behavior. You have no idea what that additional behavior is because it's only listed by the single line. You don't see it starting the timer or stopping the timer. You don't know when it does this. You don't even know what it's doing to your inputs.
It doesn't have to though. You don't
Doesn't
have to
have
use, you don't have to use attributes to do the decorator pattern.
True, but it's one of the most common forms that people start seeing first. The most easy example being bracket HTTP GET.
Okay.
But you're right, you don't have to do it with decorator patterns like that. But that is the way I would expect most developers to become aware of it first.
I'd say I've never actually seen anything C# not using attributes. I'll say that. Like it's just it's such an unusual pattern to see in general because it's weird to look at. That yeah, you probably won't see it anymore.
But anytime you find, I have this behavior already, I want to keep doing that behavior, but I want to add a little something to it. Well, you could, block end it with console logs, or you could wrap a decorator around it. And especially when you're talking about something that's just a cross-cutting attribute, logging, authentication, blah, that doesn't have anything to do with the coded behavior, the do the thing, decorators are the pattern that are most commonly applied. Or you might hear of them as middleware. Those are decorators on like an HTTP route call. This is your visual analogy. If you guys haven't seen this, this is a Christmas light timer. It turns on when the timer ticks to one of the greens, and it turns off when it ticks to one of the reds.
That was my alarm clock in college.
Right? Light on!
Yeah, turn the light on, like right here.
Right here. Right? But this thing will just keep going. You plug it into power and leave it alone. And as far as you're concerned, power's still on. The thing downstream, only on when the clock's on. But that's a decorator. It added behavior without actually changing the interfaces. Power goes in, power comes out. Now, aside from obviously being both a decorator and used for decorations, the decorator pattern is a form of metaprogramming. I have this programming concept thing. I'm going to do more with it. Don't worry, I didn't change it. I just monkey patched something on top of it. By the way, that's what it's actually called in more duck typing language like Python. I'm going to jiggle bits, and here you go. Thankfully, typed languages like C# actually compile so you know what it is mostly before you do it. Because technically reflection allows you to change it too.
You can monkey patch with reflection too.
But decoration is one of the really awesome but also utterly terrifying forms of programming because it is completely transparent to the function inside. The function inside has no clue what happened outside of it. All it is it can trust the inputs and pray that those are safe and do its behavior. So there are some possible disadvantages for misbehavior. Because technically the decorator can edit things on the outbound side too. So if your decorator that you wrote misbehaves, you could end up polluting everything you touched. Welcome to aspect-oriented programming. But it allows for a lot of flexibility, especially when I've got, say, an old existing system and I need to do something a little more, but I can't go modify everything. Right? It is the quintessential answer, by the way, to how do I do just a little bit more without having to refactor everything? Aspect-oriented programming. I'll give you an example of how I specifically did this. You guys can read that one?
It's getting strong, getting hard.
Okay. No, that's fine. I don't know if I can zoom this. No, go back.
Tim, tell improving to buy like 1 TV to 2 TVs next time. It's twice as big.
Something like that. So I'll describe, right? I needed to add a bit of telemetry behavior to every single API method because I needed to check, you remember this one, what users are actually hitting this. Not what APIs, not what sub-APIs. Are there any actual users and what zone were they coming from? I don't want to add logic to check the zone to every method. Plus, it doesn't actually matter on the get indices method or the get deals method. Those have no idea. They don't care about the user. They just care as user authorized for the information. So I don't need to add this. It doesn't belong to authentication. It doesn't belong to, well, it's kind of belonging. So how do I do it? I write a decorator as an action filter attribute, which is called SomeDecorator, and it takes some configuration. In my particular case, the configuration was the name of the page that was being visited, and maybe it's business line. Then, I actually have this function on executing the moment you're going to invoke. Do the same real quick. By the way, fun fact, you can actually get the DI container off of HTTP context. I didn't know you could do this at the time. I found out while implementing this. Yes, you can actually get access to the services. So dependency injection. I could grab the setup dependencies of the entire API, the entire C# code base from inside an attribute, but I couldn't get them at attribute setup time. I had to grab them as part of HTTP context.
Yeah.
But once I got that, I got my telemetry service and off to the races. And then when I'm actually here in my controller, I just have my get method and then I add a decorator. Now, here's a fun thing. Does the order of the decorators matter?
Yes. Authentication, right?
Authentication has got to go first. Because otherwise it's going to start executing behavior without knowing it's a trusted person. And by God, make certain you can't bypass authentication. You think I'm kidding? There was a guy who accidentally wrote that code into the middleware for authentication of a very popular Node.js web framework.
The Astro?
I don't think it was Astro. It might have been. It might have been one,
Next
but
or one of those.
yeah,
One
it
of
was,
the
it
big
was one of those like, oh dear God.
Yeah.
That was a 0-day vulnerability. Like the moment it's out, everyone you have to know. But auth goes first. After that, it's a choice, right? When do you want the timer to start? Probably right before you actually start invoking things. This is the last one. When do you want logging to start? For this, it just needs to fire at the moment you enter the method. So I don't care that it's before or after. Do it right before I start going. So we do it after it's declared as an HTTP GET. Does that change things? Technically, yes, because now HTTP GET is not getting just this public async task with this. It is getting that on top of my task. And then it's doing this. Thankfully, because it's transparent, HTTP GET doesn't care. You have to remember that that flow of control changed. And that may create problems for you down the road if you have an expectation of the changed types inside your decorator. Mostly, aspect-oriented programming will save you from this. But sometimes you get yourself in trouble. I'll give you another example of how I've made use of this one. This one is aspect-oriented programming, but I've also made use of this for testing. In fact, I had to write one of my own recently. Mostly because we weren't allowed to import the library. Yeah, what can you do? They had the wrong license. But this is all it was. This is in the JavaScript form, but you can do the same thing in C#. I said, hey, I'm going to create a function called spy on, and I'm going to hand it a method. What's it do? Well, it's a class, or create a class, that has a little extra details, duck typing for the win, and a straight regular invoke. So when you call the spied on function, it's going to call transparently to the original function, to this method that I handed it. But it's going to do some extra stuff first. Take an invoke with whatever you've given me. I'm going to say I was called at least once. I don't know if I succeeded. Don't care. I'm going to grab what you sent me, and I'm going to try and call. But I'm not going to enter the result back just yet. I'm going to take a copy. I'm going to send it back. Transparently now, any method that I've decorated this way will be spied on. I can see everything going on inside. Why is this useful? Because testing. Did I call a method? How many times did I call the method? Did I call it the right things? Did it give me the right results back and I just didn't finish bubbling it up? It works. Great for testing strategies. But because it's now transparent, I don't know what all behavior's been aggregated on top of this thing. And if I have one that misbehaves somewhere down the chain, it's entirely possible that the behavior of my system starts to become idiosyncratic because of the ways that are treating my methods that aren't obvious to me because it's transparent. It's just this method of this type. Only it's not. It's been added to. It's been modified. Suddenly the rules in the matrix changed. So there are advantages and disadvantages, most of them corresponding to can your team reason about this structure? that you have added to the function. The onion metaphor from 2 or 3 slides ago, that one. That's the best analogy I've given for teams to try and reason about this.
Does it also apply that the more you use it, the more the code base smells bad?
Actually, I'd rather like the
Use
smell
it
of
with
onions.
limitation. Yeah.
The real trick is you gotta avoid the moldy onions.
There you go, there you go.
Right? You need to make certain that none of these layers starts turning gangrene, okay?
Got it.
But because it's transparent, it'd be hard to figure out which layer is the trouble. But in all of this, having it in your back pocket can save you from situations where, like, I'm writing playwright tests and they don't include an adequate spy for the behavior I'm telling it to use. Write your own.
So compared to the other patterns, this one definitely seems to be more like use with care.
Very much so. Because it is so easy to get yourself screwed up if you're not very careful with the collective behaviors. But when you run into a situation that is, this doesn't belong as a concern purely for this method or purely for this class, it hits everything, decorators all the way. How do I know which one? All right, now, here's the point in the talk where it's appropriate to talk about how do I know which pattern I should even use. And the answer is, well, it depends. But each of these solves a slightly different problem. Strategy. If you see yourself adding yet another kind of behavior for a special situation, calls for a strategy. Yeah, but I don't want to use it like that. Might be a case for an adapter. It might also be a case for just deal with it. Depends upon whether adding the adapter truly makes a difference in the flow of your code and abstracts a concern. For example, holding on to a token used to say, yes, I'm allowed to use this service. An adapter is appropriate for that, right? If it is centralizing a concern that doesn't need to be peppered throughout your code base, an adapter would be a good fit. If you've got this really weird interface and you don't want to spread the knowledge of how to use that because it's very odd and specific, a facade, the super adapter, might be appropriate. But recognize that when you're getting into that, you're getting into interface design, this domain-specific language type stuff. Exercise some caution. Useful, powerful, more burden on you. When you get down to decorators, my sniff test, check for moldy onions, right? Don't do too much. Because remember, this thing is going to be added on top of whatever you're actually doing. Small, but thin. And with that, check that it truly is a cross-cutting concern. Authentication, logging, debounce, timing. Not, well, make certain that this and such computation is also done. Yeah, just add that to that.
I would add, like, the general rule with any uses, any design pattern usage is the goal of all of these is one is encapsulation, right? And if what you're doing doesn't actually help you to reason less about other parts of your code base, then you shouldn't be using that pattern, right? It's probably a misuse. Like, there's definitely been companies that have gone and the whole "it's not invented here" mindset. And so what they've done is they've gone and they've decided entire, front-end toolkits or, entire ecosystems of things, right? That now that code base is locked to some ancient version of, whatever that toolkit was. They'll never be able to upgrade. All the developers hate it.
Yeah. And the guy who wrote the facade originally is out.
Oh, for sure.
Like, he retired a year ago.
Absolutely.
Right.
So, exercise your best judgment, but the place to start is to make certain they actually get it. Now, one of you asked, hey, how do I actually get a team to start doing this? It's a trick question. The short form is you don't force them, though you can, but if you do that, I can guarantee you they're going to do the not invented here syndrome problem,
Yeah.
where they're going to say, it's a strategy now.
Do it
That's not a
everywhere.
strategy, that's just a whole bunch of stuff.
Yeah.
Rather, I would start similar to what you saw tonight. Walk them through and show them where it's useful. And apparently I stepped on something. Walk them through, show them where it's useful, and why did you do that? Figure that out in a second.
There you go. Yeah,
Oh, look, it worked! But help them to understand, right? The way you get them to do something new is you help them see it was useful to what they wanted, right? You can lead a horse to water, can't make them drink, but thirsty horses are more likely to. Help them solve real problems. problems. For me, my go-to almost always is, I'm gonna pull out the strategy first. Every major project I run into where like there's this massive accumulation of stuff, it's like, oh, here, factory plus strategy. They see the value and they start asking me for more design patterns. Done. That's how I also ended up doing this decorator pattern, right? Oddly enough, same code base with all of those index computations that I had previously solved with factory plus strategy. These patterns are for you to start with, because now that you know, you can smell, wait, that smells like a strategy. Adapter. Share how you learned your sense of smell with your team, giving them a sample set of onions, or a sample set of adapters, or an example in the code base where a strategy would probably be useful. But don't just start trying to invent it. These things emerged as the common response to common problems that we encounter all the time. And so you'll see them in the wild. When you spot one, bring it in. Start with you. Does that kind of cover the question? By the way, as a fun fact, if you guys would like to get access to the slides tonight, I've got a place where you will be able to download them, because I find that especially for this talk, the examples will be most useful. They're the ones that are going to build the understanding fastest with a team that's never seen this before. Now, I want to take a moment one last time to pause for questions on any of the patterns, any of those we haven't seen, except for the pivot from wrong design. That one I haven't gotten to yet. We'll save that one as a thing at the end. Any other questions on these patterns? Okay, so we asked about agentic. We can get there, but I'm going to get through the slide deck first because I need to switch applications. But I'll give you a preview. The simple way for dealing with agentic is to prompt with the pattern name. I want to create an adapter around this with this interface. I want to extract this and this and this as strategies. What should the interface be? Or I have this other strategy, pull out these other methods to that. Be careful on that one. AI likes to rewrite things, so you tell it to do a refactor, it's more likely to do a rewrite than a refactor, be advised. Now, I like to put these things into practice. The most useful way you can do this, remember I said start with you? Put it into practice. These same patterns, minus the decorator I think, show up in this book. Now I've written a bunch of different books, but if you'll sign up for the newsletter, I'll send you a coupon to get that book, which is going to be 10 small daily exercises meant to fit in about 15 minutes for free. This will allow you the chance to put those into practice, the factory, the strategy, and probably the adapter, if I'm thinking correctly. And it's a guided exercise. Here's the example, go do it like this. Including go to the back of the book and see my example of how I built this thing out. It's pseudocode, but it's a deeper dive if you want to go and put this into practice, and that really is going to be the key thing. It will also encourage you to try out different programming paradigms as ways to kind of get a sense where I was showing you guys. Object-oriented was solving the problem that got solved by functional, by wrapping a function inside of a class. A lot of our languages allow multi-paradigm approaches, which means you get to pick. Is this problem the best fit for a functional, an object-oriented, or a procedural approach? There are benefits to each. Being able to practice in different languages that force you down this paradigm or that paradigm actually allow you the opportunity for choice. C#, as an example, is multi-paradigm. You just have to choose how you use it. The most common paradigm is object-oriented, and is the one I recommend most people stick with. But if you can code switch to functional, you can unlock some superpowers every once in a while. So, free if you sign up for the newsletter, but if you want the slides, I'm going to ask for a little bit of feedback. It helps me to improve these talks, helps me to get a sense of if I'm giving value in these talks. But I figured, value for value, you're giving me feedback, I give you slides. And you'll be able to have all of those except for the one that's the giveaway, and of course this, so that you can have that for reference if you want to use it with your team, or just for your own reference. Now, of course, if you want to have someone come and give this to your team, because one of the other odd tricks is that if you ever try and teach someone yourself, they'll listen to you only as you agree. But if you call in an outside expert to give them the same lesson, all of a sudden they're listening right out of the palm of the hand. Now, this is stuff you've been telling them for months. It happens, it sucks, I can help. Tag me if you want to lead a team through this, because I can play that role of, you've probably already been hearing this, here are some examples I found that helped me. I've had more than my share of teams where the only thing I did was be the outside voice, and the team lead already knew what he needed to say. Sometimes you just need a little help. All right, everyone who's got it, who's going to scan it, scanned it? Wunderbar. I see a couple of people filling that out. Thank you, gentlemen. I'll pause until you're there, and there's my water. So here are the 3 takeaways. If I had to pick, here's the things I think make the biggest difference that aren't the images themselves in the slides. Number 1, strategy, adapter, or decorator, all of them are just about adjusting function and behavior. Strategy is to wrap it into a class, adapter is to change how you get to use it, decorator adds a little more to it without making it look like it. But each of those simplifies its own classification of problems, right? There's an entire classification, cross-cutting concerns, that the decorator is tailor-made for. Extension without modification, open-close principle. Strategy pattern. I've got this thing, but it doesn't fit my flow. Adapter. Having those in your back pocket and knowing the symptoms to look for means that you're now able to go out and solve this class of problems easier because there's a predictable way to solve them. But all of this predicates itself on essentially pulling a little bit of functional-oriented design into your object-oriented programming. And when you do that, you gain access to a new way to look at the world, a new way to solve your problems that won't be available to your peers who are only solving them in OO. So, learn to be a little flexible, and you'll unlock, in and of itself, new approaches to your problems, even beyond these design patterns. With that, thank you for your time. Now, y'all want to see me actually go through and prompt the agent on how to do some of this? Sure. All right. So. All right, now that I'm in my test area, I'm going to scoot that.
Windsurf.
Yes.
I haven't seen this live.
I have made lots of use of windsurf of late. I hardly enjoy it. So I'm going to create a new thing. What I'm going to do here is I'm just going to call this is buzz. Yeah, well, you can say that.
Looks suspiciously like Visual Studio Code.
Yes. So, I'm going to show you in JavaScript just because I happen to have Node already running this machine and I don't have C# or Mono. Sorry, guys.
What's wrong with you?
Nothing. Sorry, I'm a recovering front-end developer. Sorry, guys. But the way you would prompt this is say, so I want to implement isBuzz in, and I'm going to tell it this particular file is buzz. Of course, just buzz.js. Simple, right? Extract the printing for each response into its own function. This just being the functional approach to strategies. I don't know if this prompt will actually work, but let's see what happens. Yep, that's essentially what I wanted. So it's going to assume all of those are console. Why is it complaining? Did I do something wrong? Nope, it's just going to do that. All right, well, copy, paste. This is the code that it produced for us, assuming I didn't miss something.
No, you had to wait for it to finish.
No, I forgot. Sorry. Too eager. There we go. So now if I tap complete, FizzBuzz calls itself with FizzBuzz 100, and if I come down, come on, there you go. So it's there, yep. So if I do node dot slash is gotta love typos. There you go. Boom, FizzBuzz. Now, if I look at the function, you'll notice that it's just this for loop. Fizz, FizzBuzz, fizz, FizzBuzz, all these things. Okay, that's not too strange. What if I want to extract from console logging, I want to just capture to a string? At this point, I need to change what it's doing. I'll need to initialize all of these. That'd be an example of one of the refactors. I could instead try and say, hey, on variables of 10, don't just print buzz, I want to add a new thing. Let's try that, because that's more like your extension case. I'm going to say, add a method to print Tony on multiples 10. In theory, it should now rewrite this thing. Good. Accept. And now on multiples of 10 and multiples of 15, we'll do this thing. Now if we rerun, we'll see that we should get a. Yep, I saw at least one Tony. There we go. 90 is Tony. Yay! But you'll notice I'm still just aggregating speeds. This is one of those moments where I'm seeing that need for a factory. Right? So instead of doing this if-else loop, I'm instructed to refactor the FizzBuzz method to call a print factory method that takes the index and returns the function to call, which prints the correct value. Let's see if it'll actually do this. But this, you saw I fed it the pattern name, refactor to extract a factory. What's the factory return? Well, it takes index and it returns a function to call. Now, if it does this correctly, what it should do is essentially this, but return a function. And you'll notice it created a lambda for the print of index value. Because it doesn't want to turn a function that now has to take index. It just wants a pure call print. So how's it going to do this? Let's take a look. And now print factory has print Tony, print FizzBuzz, print fizz, print buzz, print number. And print number is a lambda. Or closure, depending on how you say it. Because the interface for this is just a call. And if I accept that change, the const print function is equal to print factory, call print function. Let's check. See at least one fizz, Tony, fizz, FizzBuzz. If I feed FizzBuzz, FizzBuzz. The value in this is that you use the name to describe the behavior you want the refactor to be. Refactor this to a factory. Add a new strategy. And link into decision trees. This allows the AI, which is loaded with these terms itself, to recognize what you really want it to do and make it more likely that it produces the change you want. Now you saw I did have some idiosyncrasies here where I was trying to get it to work the first time. But being able to feed it those pattern names makes it more likely to have the behavior you want, provided you're using the right pattern name. So, more than just these three, go look up the original gang of 4 and learn the rest of them to gain, essentially, refactoring superpowers with AI.
What's the four? What's the four?
Gang of 4?
No, gang of 4. So the design patterns overall are split into like 3 broad categories: behavioral, structural, and creational patterns. And there are about 12-ish that they originally came up with. There have been more added since, but factory, strategy, decorator, adapter are among those. So if you want to learn the rest of the 12, like flyaway, visitor, and a couple of others, go look up the original set, or like check out the Wikipedia page, and you'll get a good sense of what the other patterns that exist.
Yeah,
What's the book called? It's like patterns.
The design patterns,
Architecture.
elements of reusable object-oriented design.
I think that's the original.
That was the original book.
I remember reading about it in a book called Design Patterns Explained.
Yeah.
But there's been a bunch of books for that. Find one whose examples work well for you. I taught myself how to do these things by teaching myself how to write them in Python. You can pick it up in just about any language, but put them into practice is really the trick. Learn the language, go do the thing.
I think that explains your particular bent on how to explain these things. Really, if you started out learning them in Python, which is not an OO language, by default. So.
I mean, that doesn't help, no. But remember, I did start with C#. I promise I'm a good OO boy.
I don't know.
All right. So that got us all of the questions except how do you pivot when the wrong tech decision was made and your team morale is dropped? Now for that one, if you guys want to stick around, we can kibitz. But I'm going to go ahead and shut down my computer because that's all I have on the presentation. So, your team morale is down. Is it because your action went wrong, or because, well, management's not happy that the project's delayed?